Now let's learn about Newton's interpolation formula. Okay, so let's suppose you have your n plus 1 set of values ranging from x0 y0 to x0 plus nh yn, and you want to interpolate, or even rather extrapolate. You can do both with this particular formula. Let's see how. Let's just say that you want to interpolate a value which is nearer to the first given value. Okay, it's nearer to x0 y0, so it could be somewhere around over here, okay, or it could be somewhere around over here. Okay, so when that is the scenario, what you could do is, let's just say that the value that you want to interpolate is at x is equal to x0 plus ph. Okay, when p is positive, you are looking at values in this direction. Okay, so let's just say that when p is equal to 3.5, you are looking at x0 plus 3h plus 0.5h. Okay, so basically you are looking at value between 3h and 4h, right? When p is, let's say, negative, when p is minus 1.5, then you are basically looking at values in this direction and you are extrapolating. Okay, so you can do both with this particular formula. We are going to see how. So basically we want a value at x0 plus ph. Okay, so essentially what you have is y at x, which is y at x0 plus ph, okay, that you want to find out. Okay, and it is going to be e raised to power p y0, right? What is e raised to power 2y0? It's gonna be y2. Similarly, what is e raised to power p y0? It's gonna be yp, which is y at x0 plus ph, right? So you have e raised to power p y0, which you want to find out. Now we know that e is equal to what? My e is equal to 1 plus delta. So I have 1 plus delta raised to power p into h, or rather into y0. Okay, you can have this as small p because we have taken it as small p. Okay, so essentially this is going to be, you can expand this using your binomial theorem, and what you have is 1 plus p delta plus p into p minus 1 upon 2 factorial delta square plus p into p minus 1 into p minus 2 upon 3 factorial delta cube, and so on. Okay, and you have your y0 on the outside. So when you're going to take it inside and operate, what you're going to get is y0 plus p into delta y0 plus p into p minus 1 by 2 factorial delta square y0 plus p into p minus 1 into p minus 2 upon 3 factorial delta cube y0, and so on. Okay, so your y at x0 plus ph is going to be given by this formula, which is known as Newton's forward difference formula. Okay, because this is being calculated using your forward differences. Okay, so this is your Newton's forward difference formula, or Newton's forward difference interpolation formula. Okay, similarly, now if you want to interpolate for a value of x which is nearer towards the end, okay, so you can say that what you want is the value of x at xn, which is, let's say, this guy, plus p into h. Okay, when your p is positive, you are extrapolating, basically looking at values in this direction. When p is negative, you are interpolating, you're basically looking at values in this region near your yn. Okay, so now applying the similar analysis, I can say that my y at point x, which is this, is going to be e raised to power p y at xn. Okay, what is xn? Xn is this guy. Okay, so it is y at xn, which is yn. Now e raised to power p I can also write as inverse operator raised to power minus p yn. Okay, it's the small p. Now I know that inverse operator is equal to 1 minus my del operator. Okay, so I have 1 minus del raised to power minus p. Okay, yn. You can expand this using your binomial theorem. You are going to get 1 plus p into del plus p into p plus 1 upon 2 factorial del square plus p into p plus 1 into p plus 2 upon 3 factorial del cube and so on. Okay, and you have your yn, which is being operated upon. Now if you are going to take the yn inside, you are essentially going to get yn plus p into del yn plus p into p plus 1 upon 2 factorial del square yn plus p into p plus 1 into p plus 2 upon 3 factorial del cube yn and so on. Okay, so this is your backward interpolation formula. It's your Newton's backward interpolation formula that helps you interpolate to a point which is in the vicinity of the last value. Okay, your forward interpolation formula helps you interpolate to a point which is in the vicinity of the starting value. Your backward interpolation formula helps you find a x or a corresponding y value which is nearer to the end. Okay, so whenever you have to find out f of x where x is towards the end, you use your backward interpolation formula, and when you have to find out f of x where x is towards the start, then you use your forward interpolation formula. Okay, just remember your formulas, backward and the forward interpolation formula. Okay, let's take an example. Over here I am been given some x and y values. Okay, this is y or f of x. Using these values I need to find out the function of x, okay, and find out the value of the function of x at x is equal to 4. Okay, so as you know that whenever you have n set of values, your fx is a polynomial of degree n minus 1. So in this case we are going to assume that fx is a polynomial of degree 3, okay, because you have 4 values. So it's a polynomial of degree 3 and we need to find out f of x. My Newton's forward interpolation formula gives me f of x0 plus p into h as equal to, it's equal to your f of x0, whoops, it's gonna be like this, plus p into your delta f of x0 plus p into p minus 1 upon 2 factorial your delta square f of x0 and so on. Okay, we've seen the formula over here. We had y0 everywhere, and what is your y0? Y0 is essentially the f of x0. Okay, so I have written the formula in terms of fx rather than y0. Okay, so this is my formula. In the given scenario, your x0 is 0, okay, and your h is your differencing interval, which is 1. Okay, so what you have in this particular scenario is f of 0 plus p into 1, which is f of p is equal to f of x0 plus p delta f of x0 plus p into p minus 1 upon 2 factorial delta square f of x0 and so on. Okay, now what you can do is you can just change the variable p to x. So what are you going to get? You are going to have f of x is equal to f of x0 plus p into delta. Instead of p we have x, so we are going to have x into delta f of x0 plus, instead of p we have x, so x into x minus 1 upon 2 factorial delta square f of x0 and so on. Okay, so essentially you have got your f of x. All you need to do is find out these things. Okay, just understand one thing. Since your fx is a polynomial of degree 3, your delta cube fx is going to be a constant, and delta raised to power 4 fx and all other higher powers are all 0. Okay, so for this particular scenario, what I have is delta raised to power 4 fx is equal to 0, or rather delta raised to power 4 plus k fx is equal to 0, where k is equal to 0, 1, 2 and so on. So your formula for fx in this particular question is going to be f of x is equal to f of x0 plus x into delta f of x0 plus x into x minus 1 upon 2 factorial delta square f of x0 plus x into x minus 1 into x minus 2 upon 3 factorial delta cube f of x0. All other higher powers for your forward differences are all going to be 0. So that's the f of x. Now just find out this, this and this and put in this particular equation. So let's find out the forward differences. I have 0, 1, 2, 3 and 1, 2, 1, 0. Okay, so let's just write 0, 1, 2, 3 and corresponding fx values are 1, 2, 1, 0. Okay, your first forward difference, if this is your x, this is your f of x and this is going to be your delta. Okay, your first forward difference is this minus this, which is 1, this minus this, which is minus 1, and this minus this, which is minus 1 again. Okay, it's 1, 2, 1 and 10. Okay, so this guy is 10, so this is 10 minus 1, which is 9. Your second forward difference is going to be minus 1, which is minus 2, and then you have 9 minus minus 1, which is going to be 10. Your third forward difference is going to be, it's this minus this, so you have 12. Okay, you need first, second and third forward difference for x0. Okay, so you need this value and this value. Okay, so what do you get? You have f of x equal to f of x0, which is this, plus x into delta f of x0, which is this. So you have x into 1 plus x into x minus 1 upon 2 into delta square fx0, which is this. Okay, plus you have x into x minus 1 into x minus 2 upon 3 factorial, which is your 6, into delta cube fx0, which is this. So that's your f of x. You can just simplify it, and the final answer is going to be f of x is equal to 2x cube minus 7x square plus 6x plus 1. Okay, you can just simplify all these and you are going to get the final answer as this. Okay, now in the question it is also asked that you find out the f of 4. Okay, one way to do it is just plug in x equal to 4 in the expression for fx that you have got. Another way would be to use your backward interpolation formula. Your f of 4 is going to be over here, which is nearer to the end. Okay, so when you have your x value nearer to the end, you use your backward interpolation formula, and when you have your x value nearer to the start, you use your forward interpolation formula. Okay, so I have my backward interpolation formula over here. I am supposed to get y4, okay, which is y at x is equal to 4. Okay, you have y0, y1, y2 and y3, and y4 would be y at x is equal to 4, right? So you have to get y4. What is your p now? Look, your y at x is equal to your y at xn plus p into h. Okay, what is xn? Xn is the third value or the fourth value, which is this. Okay, and you need to find out x4. Okay, y at x4. So what you want is y4, which is y at 3 plus p into h. H in our case is 1. Okay, that's the differencing interval, which is 1. So h is equal to 1. So essentially what you have is 4 is equal to 3 plus p, or your p is equal to 1. So in this particular case, your p is equal to 1 and your n is 3. Okay, so I'll just write it down for you. Your n is equal to 3 and your p is equal to 1. So you have the formula like this. You have y4 equal to yn, which is y3, plus p, which is 1, into del y3 plus 1 into 1 plus 2 upon 2 factorial del square y3 plus 1 into 1 plus 1, which is 2, into 1 plus 2, which is 3, upon 3 factorial del cube y3, and you have a term with del raised to power 4 y4. However, since it is of degree 3, okay, we've already seen that our polynomial is of degree 3, therefore all the differences starting with power 4 are going to be 0. Okay, So you are not going to have this term at all. So your final formula looks like this. Okay, now what's left is to calculate the backward difference for y3. Okay, first, second and third backward difference. But you know that your forward difference yr minus 1 is equal to your backward difference yr. Okay, so if you want to calculate your y3, basically what you want is calculate the forward difference for y2. Okay, you've already calculated your forward differences. Okay, this is the forward difference for y0. Okay, this is y1 and this is y2. Okay, so you want this, which is the first forward difference for y2, this is your second forward difference for y2, and this is your third forward difference for y2. Okay, you have already calculated them, you need not calculate again. Okay, so you have 9, 10 and 12 as the values that you want. So basically you are looking at y4 is equal to y3. What is y3? y3 is this, which is 10. 10 plus 1 into your first forward difference y3, which is 9, plus this is equal to 1, your second backward difference y3, which is your second forward difference y2, which is 10, plus this is again equal to 1, and you have third backward difference y2, which is 12. So you have 1 into 12. So what you have is 10 plus 9 plus 10 plus 12. Okay, so you have 22 plus 9, 31 plus 10, 41 is the answer. Okay, so your y at x is equal to 4 is 41. We have calculated the polynomial also. Okay, let's see what do we get when we put x is equal to 4. So we have 2 dot 4 cube, okay, which is 64, minus 7 into 4 square, which is 7 into 16, plus 6 into 4, which is 24, plus 1. Okay, if you are going to calculate this, this also comes out to be 41. Okay, let's look at another problem. Over here we are supposed to find out the students with marks between 40 and 45. Okay, it is given to us that there are 31 students who are getting 30 to 40 marks. There are 42 students who have marks between 40 and 50. There are 51 students who are getting marks between 50 and 60, 35 between 60 and 70, and 31 between 70 and 80. Okay, we are supposed to find out how many students have marks between 40 and 45. Look, our interpolation formula is going to work when we have specific values for x. Okay, you can think of this as your x and this is your f of x. Over here we have ranges. Okay, we want specific values, so we are going to convert this into a cumulative frequency table. Okay, so let's just say that I have my x and I have my f of x. Okay, so for x is equal to 40, I define f of x as the number of students who have got less than x marks. Okay, so as I can see, for x is equal to 40, I am going to find out the number of students who have got less than 40. Okay, so there are 31 students who have got less than 40. Okay, similarly, your f of 50 is number of students who have got less than 50. Okay, so it is 42 plus 31. Okay, 30 to 40 is also less than 50, 40 to 50 is also less than 50. So you have 73 guys who have got less than 50. Okay, So basically we are creating a cumulative frequency table. Okay, so you just add them up. Similarly, what is your f of 60? It is going to be 73 plus 51, which is 124. Okay, and then you have your next x value, which is your 70, and your f of 70 is the number of guys who have less than or equal to 70, you can say. Okay, so it's going to be 124 plus 35, okay, which is gonna be 159. Okay, so f of 70 is 159, and finally we have 80, and my f of 80 is 159 plus 31, which is going to be 190. Okay, so that's the table that I've got. So I have got x and f of x. Now the question asks me to find out the students who have marks between 40 and 45. Okay, I know that there are 31 students who have got less than 40. Okay, if I can find out how many students have got less than 45, then the students who have got between 40 and 45 is going to be f of 45 minus f of 40, right? This is the number of students who have got less than 45. This is the number of students who have got less than 40. So this minus this is the number of students who have got between 40 and 45. So now the problem is converted into finding out f of 45. Okay, so now it's a standard interpolation problem which you can use your Newton's interpolation formula, your forward interpolation formula rather, because you are finding out f of 45. Your starting value is 40, so 45 is nearer to the beginning of this set of values. Okay, so you are going to use your forward interpolation formula. Let's calculate the forward differences. Okay, 73 minus 31, it's gonna be 42. These are going to be the same as what you have over here. Okay, so 124 minus 73, it's gonna be 51. Then you are going to have 35 and you are going to have 31. Okay, so you have a 35 over here, you have a 31 over here. This was your first forward difference. Now we have the second forward difference, which is going to be 51 minus 42. So I have a 9 over here. Then we have 35 minus 51. You have minus 16 over here. And finally you have 31 minus 35, which is minus 4. This is the second forward difference. Let's calculate the third forward difference. It's gonna be minus 16 minus 9, which is minus 25, and you have minus 4 minus minus 16, which is minus 4 plus 16. So you're looking at 12. And finally we are going to have the fourth forward difference, which is going to be 12 minus minus 25, which is 12 plus 25, and that's going to be 37. Since we are given 1, 2, 3, 4 and 5 values, we are going to say that this is a degree 4 polynomial, and hence delta raised to power 5 is going to be 0, or delta raised to power 5 plus k is going to be 0, where k is equal to 0, 1, 2, 3 and so on. Okay, so you are interested in only calculating your fourth forward difference, as all the higher order forward differences are going to be 0. Okay, so here is your forward interpolation formula. You are looking at y at x is equal to 45, which is going to be y0, which is y at x0, which is the starting value. Okay, so it's going to be 31 plus, what is your p? You are looking at y45, okay, which is y40 plus 5. If you are going to compare this with y x0 plus p into h. What is h in our case? H is the differencing interval, which in this case is 10. Okay, so you have x0 plus p into 10. Okay, what is x0? x0 is 40. Okay, so you have 40 plus 5 is equal to 40 plus p into 10. So you have 5 is equal to p into 10, or your p is equal to 0.5. Okay, so your p is 0.5 over here. So you have 31 plus 0.5 into delta y0 plus 0.5 into 0.5 minus 1, which is minus 0.5, upon 2 factorial into delta square y0 plus 0.5 into minus 0.5 into 0.5 minus 2, which is going to be minus 1.5, upon 3 factorial delta cube y0 plus you have 0.5 into p minus 1, which is minus 0.5, into p minus 2, which is minus 1.5, into p minus 3, which is minus 2.5, delta raised to power 4 y0 upon 4 factorial. Okay, you won't have plus anything because all the higher order forward differences are going to be 0. Now using this formula, you can just plug in your forward differences for y0, which is this, this, this and this. Just put in those values in this particular formula and you're going to get your y45. Okay, the value comes out to be around 47.87. Okay, since this is the number of students who have got less than equal to 45 marks, we are just going to say that this is equal to or almost equal to 48, because we are counting heads. Okay, and it cannot be fractional. So my f of 45 is equal to 48. My f of 40 is what? My f of 40 is 31. Okay, my f of 40 is 31. I need number of students who have got marks between 40 and 45. Therefore my answer is 48 minus 31, which is 17. Okay, so 17 students have got marks between 40 and 45, and you have solved the question. Okay, so that's how you apply your forward or backward interpolation formula. Okay, we've seen the backward interpolation formula in the previous example, and over here we have the forward interpolation formula. Just remember, you have to apply either of these depending upon what value of x you want and how far it is from the starting position or the ending position. Okay.